Publicly released in 2015, GraphQL has been a pretty viable option for building and deploying APIs for at least 5 years now. APIs, as we all know, are pretty subjective in their pros and cons, especially when it comes to merging with our current systems of REST. So we're going to get a little bit more into that as we go, and that's kind of like where we want to start. But before we do, who am I? So my name is Lachlan Young. I'm a full-stack software developer from Australia working at a company called Tanda. Tanda is a time and attendance company who predominantly have two sets of tools. We have one mobile app and one website, one for the staff, one for the managers, and that's basically our core suite. This matters to you because each different platform has a different implementation of GraphQL and API, and I'll get more into that as we go. So why do we care about Tanda? Well, they sent me to India to talk, which is pretty cool, and we're hiring internationally. But also we run pretty viable GraphQL setups. We've been around for about 7 years, and GraphQL's only been out for about 5 years. So realistically, there's some pretty different changes there, and I'm going to walk through those as we go. But before we do that, I want to do a little bit of housework. Firstly, feedback. Please pop my bubble. I'm trying to improve just like everybody else here, and if you've got any feedback, positive or negative, I'd really appreciate if you take the time to talk to me about it. Lastly, a few talk disclaimers. I'm going to go in-depth on some topics and service level on others. An example of this is when I'm talking about REST. It's currently the most popular form of API, so there's a reasonable assumption on my end that we all know how routes and stuff work. I'll still cover them lightly, but I want to spend a bit more time talking about SOAP and GraphQL and some of the weirder stuff we haven't really encountered yet. I'll try and keep it light and cover some vague stuff, like I said, but bear with me as we go, and sorry if I skip over anything. Lastly, my experience with PHP is null. I came from Polymer, moved into React and React Native, so everything I'm talking about is going to be JavaScript related and Node related. I'm not trying to say PHP and Java and all those other stuff doesn't hold sway. It definitely does, but please be aware that's not my area of expertise. Sweet. So to start off, I actually don't even want to talk about GraphQL. I want to borrow Lee's time machine and jump back to the year of 2000. So in 2000, GraphQL wasn't a thing, REST was kind of a thing, but SOAP was actually the king in the world of APIs, and we dealt with XML and WSDL on a day-to-day basis. So in the early year of 2000, we got our first consumable APIs from Salesforce, and then 7 months later, eBay. So the APIs themselves are pretty irrelevant, but we really care about the technology powering them, and those are REST and SOAP. So SOAP actually ended up taking the official W3C specification in 2003 and has been supported since then. So back then, the web as we know it was nowhere near as responsive as it is today. We'd have to run multiple different variations of web pages. We didn't have such things like Ajax or even component-based design. So certainly we may do what we had, but a traditional web architecture would look a little something like this. So you still have a client-server system. You're powering your site, but it's more front-end heavy due to the need for different pages for different variations of information as you got it. We'd run a SOAP or a REST API. That's a bed, which is great. And we use on our client a new XML HTTP request, and that could receive either XML or JSON. For the majority of use cases, we'd be receiving XML, and that added a whole new level of complexity in regards to how we pass our data and how we manage all of our data. So our XML HTTP request would go to the DOM, and then it would get served to our multiple web pages. And it's simple, but it's also pretty complex. So I do want to note heavily that XML HTTP is compatible with JSON, which is why REST was still in the market, but at this point, SOAP and XML were the main go-tos. So where SOAP got complex, though, was in two aspects of it, server-side and client-side. So I mentioned a little earlier the acronym known as WSDL, so standing for Web Service Description Language. WSDL was the original API schema before GraphQL hit the scene. So we'll break down what this is real soon, but I just want to communicate how intense this simple WSDL is to communicate one simple route. So breaking it down, we've got the types, we've got the messages, the port types, the bindings, and then we also have the services. So keeping in mind this is still for HTTP web API, let's kick it off with types. There are two types in this simple request response. And it's an input and output. So since we're using a string, in this case, we don't actually need the complex type wrapper, but if we were to pass something such as an object, we'd end up defining it as a parameter, and that would need complex type declaration. So following the types, we have the sequence. This doesn't matter too much for us right now, but if the order of how we got arguments was important, we'd utilize sequence. And then finishing up, we have our actual type, which in this case is defined as an element username with a type of string. So this defines the expected arguments of our request to be a string, which is username, copy, paste. We've got the same thing for our response, and that's also a string. So basically, since we aren't using this, we just want to churn the argument username back to the client. Now, in order to manage and implement these elements we defined as types, we need to specify what the message is. So one message for input and then one for output. So the definition of these is pretty straightforward, but then we end up passing it later down to port type to kind of tell you what's happening. So in this case, we've got two. We've got the example SOAP request, which has the element examples. We know that's a type string. And then we also have the example SOAP response, taking our example response, which is again type string. This would vary dependingly. Your mileage will vary depending on what you've got, but that's essentially how you would define a basic WSDL. Two more remaining bits. We've got the port types, and later we'll cover the services. But the point of a port type is to define the expected trip. So in a REST world, this is pretty similar to a route, which we all know. I'll lightly cover that later. But in this case, we know we have two messages which require different elements, the input and the output. In port type, we define the input. And then we've got also documentation if you wanted to browse your WSDL, much like you would with a GraphQL schema. So forgot about bindings. At this point, so a binding is essentially a building block. This is, in this case, the same as a port type, but if we were to do any complicated decryption, security, ACID compliance, all that stuff, that would all be going through the binding. And then we take the binding and we wrap that into the service. So the service is just like our single point of truth, our GraphQL endpoint. It's the same thing, we just wrap all of our ports. In this case, we only have one, but if we were to have multiple, we would put those through there as well. So taking this complex WSDL and reading it into your server, listen to its SOAP extensions with the relevant node packages, then mapping it into our service with SOAP. We've kind of got a decent SOAP endpoint to churn a value, which is a username string. So in this case, it's going to be Lachlan, but in order to do that, we now need to interact it with two variables. So we can either use a client with a specific setup using XML HTTP request, or to make it real easy, let's use Postman. So this is a Postman SOAP request. It's using the following structure, and a lot of us have seen this. It's a little bit different, but we're using an envelope, a header, and a body. So since our SOAP request will be in this scenario using XML, we need to define the start and the end of our message with an envelope. And inside of that, we can declare optional parameters and all that stuff using the header, and then the body works as you'd expect. It's pretty stark similarities between REST. So I mentioned earlier that SOAP is the W3C standard, and it still is to this day. Simple Object Access Protocol means a lot more than what we can get in REST and GraphQL. It means we can connect over FTP, SMTP, and other protocols that we don't really get when we're working in the world of HTTP. So with this extra possibility, however, there comes a strict level of difficulty and complexity in regards to how we decrypt our XML, how we manage our data, our expectations, our ACID compliance, as I mentioned earlier, with security and authentication. And this is all really stuff that doesn't really have a place in majority of websites today. So I'll cover it in a little bit, but our websites real quickly modernized, and we no longer needed the slow APIs to work with the slow front end. We needed a quick API to work with a quick front end. So this is where SOAP started to really lose in the race of the World Wide Web. So in 2006, jQuery was released, and the web got a big upgrade. So we now had quicker, responsive websites, which paired with Ajax a year later in 2007, really changed the web as we knew it. So that gave us quick, responsive websites. We no longer had to render different pages on different variations of data. We could pass stuff into forms, render in the background, update as expected. So standing for asynchronous JavaScript and XML, Ajax really catapulted us into the next era of the web. With a quicker front end, though, we needed a quicker API. And if only there was an API which ran purely on HTTP, allowing us to smoothly request and receive data in a readable format without any of the complexities around parsing and decryption that SOAP required. Enter REST. So when we paired Ajax with our document system of XML HTTP to the DOM, we can now utilize asynchronous requests. And the upgrade this gave us was staggering. We can now have a simple, easy to decrypt API serving us data in a structured yet manageable format, allowing us to easily define our endpoints and work with it at speed. So, security was still just as easy. You now no longer, instead of defining explicit types, you now just assigned a token or a cookie or whatever you did into your header, passed it through, read it, and handled it in the server. So this is all good, but there is, as there always is, serious trade-offs. So yes, we could easily interact and manage our client-server relationship, but we also needed a variety of manual checking on the server. We could no longer just assume that SOAP was managing what was expected. So the collection of port types that we did have in the past is no longer valid. So we need to handle the expected workflow with the expected values and ensure that everything matches up. And over time, what started out being simple yet monolithic and gigantic really became an eyesore. And a few people are going to cover this as we go, but eventually your routes turn from being one simple aspect to 100 different complexities to add a cat, a dog, and a rat. So your GET request to retrieve your users was now diluted and as complex as SOAP without any of the benefits of explicit type checking. So at a previous job of mine, this is a pretty good example. We ended up having a serious circular dependency issue where services would call other services and opening us up to potential memory leaks or even worse. So we refactored it all into a route controller service mix, but included, we also had an entirely custom error message. And this would throw things such as missing parameter or not found. This is obviously handled in different ways in the client, but it allowed us to heavily communicate to the users what was happening, manage what was happening, and then also do a ton of type checking. But this was all functionality that was included in SOAP up until when we decided to use REST. So the benefit of a quick and easy to use API was all of a sudden bloated and unnecessary because of all this additional type checking that we didn't really need, but we did need. And then on top of that, we had to check the different types of the arguments. So if I'm giving you a username, is it a string? Is it an ID? SOAP had that covered. And GraphQL has that covered, but REST doesn't. And now you've got a ton of bloatware, which you don't really want. So I should stress, REST is still a viable option. It's quicker, it's more effective for websites as we currently stand, second to GraphQL. But at the time, there was no better solution. We still wouldn't use SOAP, but it's something to consider, and you definitely bloat it out. So now we're in the world of REST, but moving forward, we've got a few more years until our front-end stack catches up to the newfound speed. And at this point, it's a little bit ironic that GraphQL actually came out in 2012 internally, with React coming out a year later in 2013. So when they did that, the web as we knew it took a real serious shift. And this is when we moved to where we currently are now. So as I mentioned earlier, we already had a peek of what could be possible because there are other frameworks out there like Google's Polymer, which is again component-based design. But now, with the component-based design of React and also with Polymer, we had this whole new world of revolving internal logical functioning, JavaScript, CSS, dependent on different variations of API calls. So, and this was only further proven later in mid-2018-19 when React officially overtook jQuery on Google Trends. So throwing it back a few more years, GraphQL was made public in 2015, like I said, and then it was built on and extended with community tools and private tools such as Apollo, Relay, and Prisma, giving you the systems that you currently see today. So, how to convince your boss to use GraphQL? Well, now that the history lesson's over, let's dive into that a little bit. So, I did say I was going to assume some things, but before we do that, let's cover some of the basics quickly. At a high level, GraphQL has 3 methods, or in my mind, operations. Your get will become a query, while your post, put, patch, update, and delete will become a mutation. And then if you've ever run a pub/sub situation, you can use subscriptions for that. So, and now you're completely on the GraphQL system. However, before you jump into the entire ecosystem, you need to know the trade-offs. And at this point, I'm talking to you, the juniors who want to use GraphQL, and the seniors who are rightfully wary. Let's get a little controversial. Well, not too controversial, but now hear me out. What if you could take the heavy typing, serious routing that SOAP was known and loved for, and overlay it into the insane speeds of REST? This is where the world of GraphQL really starts adding some value to our lives. And if you've ever seen me talk before, you'll recognize I love to throw this slide around. But to me, there's always been an extra layer of complexity to this. And to me, it's a conversion of the REST that we know and love to the heavily typed managed port types of GraphQL. It is my strong opinion that GraphQL is actually not an API. It is instead a layer intended to integrate and improve our lives, whilst also maintaining a healthy respect for what we currently have. The reason I went so in-depth on SOAP was to highlight to you just where the similarities lie between GraphQL and SOAP. Treating GraphQL as the layer I believe it to be, we now have types back. Where we once had port types, bindings, services, messages, and more, we now have resolvers. So in the world of GraphQL, we don't need the complex data structures XML was giving us. If we heavily type the query and the mutation values, the benefits of running lightweight JSON can be fully utilized without any concern for incorrect use or misdefined parameters. So to me, GraphQL has all the benefits of SOAP with the speed of rest designed for an HTTP secure environment. Let that sink in a little. So all this is easily said, yet is it easily done? Well, let's give it a go. Take a look at this server configuration I'm running for a REST API. So we've got 3 routes, one for all our users, one for a user based on a provided value. In this case, it's a janky username, but for you, it would probably be an ID or a UUID. And then last but not least, I've thrown in an arbitrary route, get legal users, which will return all users over the age of 21. So this is pretty simple, but it's also super complex. In addition to the data searching, we've got multiple cases of error checking. Every route is wrapped in a try-catch, and then it's all routed back to the main server endpoint. So in pink, I've blocked out our try-catches, and then in purple, I've blocked out our error checking. And considering how simple these routes are, we can condense them further into ternaries, but you get the idea. There's all this bloat to our code, which is necessary, but really not a huge deal. And if you run this with 100 plus routes, you're going to be in a world of hurt if you end up changing something, specifically anywhere the way you handle errors. So if we convert our designated routes for GET to GraphQL queries, we're left with the following. So this is much easier to interpret. So our complexity is still there. We've just extrapolated it into a .graphql file. Specifically, we have 2 parts now. So the GraphQL file is in the pink border. And we have a resolver, which runs the queries, mutations, and the subscriptions. And then we have our schema.graphql file, which we read into our server. There's a similar implementation solution using a code-based approach, but for this, we'll keep it pretty simple and stick to a .graphql file. So by doing this, we're now able to implement our previous routes. We're going to increase the speed of our server. We can implement strict type checking, and as an added bonus, we can improve the overall readability and usability by our developers and the server code and the people that use it everywhere. So if you pair that with a responsive web-based implementation, so let's say React, you can easily query and load all the data you need. You can take it up a notch, and then you can edit a user's data. You can submit a mutation, rely on optimistic response, refetch. The speed of your entire platform is going to vastly increase. And Bob's your uncle, your load speed is now hugely improved, not to mention confined. And following the GraphQL model, you can now truly get data as you need it. And you don't need a ton of variety of routes and all that stuff. So you want all users, but you want only their name. What about if you want their name and then you also want their age? Well, now we no longer need different routes for this. You don't have to change anything besides just add one word to a query string. So now granted, this is small time. If you're running another 97 routes of your 100, you're going to have some pretty weird and wacky roadblocks coming your way. And it's at this point that you want to rely on the context tree and the knowledge of your internal devs to get you through. So let's kick it up a notch again. In my limited yet varied experience, I've implemented and ran 3 different variations and configurations of GraphQL. The best example to pair with what we just spoke about is Tanda's current GraphQL implementation. And I mentioned before how we run 2 main applications in our suite of tools. So we run a mobile application and a web app, one in React Native respectively. And both of these are built using React together internally on the same code base, with our mobile app existing on a separate code base. So the API, regardless of what tool it powers, exists for our web app. So, but like I said, Tanda came out 7 years ago, so GraphQL's been out for 5 years ago, and we realistically didn't really look at using GraphQL for 2 years. So instead, at GraphQL at Tanda we run a REST API, which we call V2, and then we run a GraphQL API, which we call V3. And the reason we did this was because up until that point, our app, which was meant to be quick, fast, consumed on a daily basis by employees, was sitting by the wayside as it got caught trying to interpret this bulky, massive REST API without any constraints because it's designed for the website. And the REST API is fantastic, but when you're on limited internet or crappy hotel Wi-Fi, it's really not the best situation when you want to check when your shifts are in a time and attendance world. So additionally, on top of that, our API needed to be scalable. So Tanda's an international company, like I said, and our React Redux approach was pretty questionable at times. It didn't work great for us in Australia, let alone other people around the world when our database was in Australia, and we needed to scale this and provide as many advantages to ourselves as we could. So we changed it. Over time, we ripped our Redux store apart and replaced it with Apollo's caching. We loaded data on demand, depending on when we needed it in components. And amongst this process, we had one big trick that allowed us to save a lot of time. See, our problem was always getting data, specifically getting it in a reliable time frame. So much so I haven't covered mutations once in this talk yet. So we already had all these useful routes for posting data where we needed, so we implemented a hybrid approach. Our mobile app, it currently runs at a 98% stability rate. It's #1 for time and attendance in the App Store and has an abundance of positive reviews. So the secret to success for this was to utilize the speed of GraphQL queries as needed. And in the limited time we did submit data, for example, an employee submitting a leave request, we would post to our V2 REST API and then just call a refetch after that. So in a perfect world, we could take advantage of mutations and their optimistic response, yet for us, this works much better and the query itself runs as you'd expect with loading and error handling built in. So we really got the best of both worlds without having to maintain different variations. So like I said, there are quite a few big benefits to doing this, like not having to maintain a separate API. We don't have to get it all complicated and show a V3 and a V2. The V3 is purely internal. It runs only for aspects of our website and our entire mobile app. If we ever needed a resolver to be publicly available, such as a client requested or an enterprise customer needed it, we could just transpose the same logic that goes into the resolver over onto the REST route and Bob's your uncle. So additionally, everything's in sync. We don't have any complicated logic. So our API authorization is the same across the board. We don't need to manipulate it or do any weird checking with it. It's super scalable and perfect for what we needed. So on the other side, though, of that publicly available monolithic beast, we had a little mobile app which was GQL and microservice focused, specifically running a serverless system. So the big issue with running a GraphQL API at a company is how do you make it available for others for integration? See, it's not easy. Not a lot of people want to or even can consume a GraphQL API. So there are some situations where this doesn't matter, and our prime example of that is this mobile app that I worked on for Moreton Bay Regional Council in Australia. So something we had to plan for when scoping out this app was the demographic of the council. It was believed that the majority of the users didn't have some of the most modern technology, and we had to scale for different internet speeds because internet speeds are not great in Australia. And the implementation was a little trickier to implement than our web equivalent. So this all happened late 2018, and we were using a serverless system when serverless and GraphQL had really only just been married. So there are a lot of problems and pain points, and serving your entire schema system through to the client was interesting. In an EC2 TCP server-hosted world, you can make use of Apollo server, and that would transpile and send your schema across to the client as you'd expect. However, in a serverless world, you really don't get that benefit. So instead, we had to serve our app using AWS AppSync, and that would compile our schema and serve it to the client as we'd expect with one endpoint. So we can either tie our all system to a system like Cognito, because that's the only way you can interact with AWS AppSync, or you could use a custom auth system, and let me just give you a heads up, that's an absolute minefield. So we ended up using Cognito, which isn't super applicable to GraphQL, but it does highlight the point that the more stuff that you build onto with serverless, the more abstract and complicated and confusing it gets. So even simple stuff such as Facebook and Google single sign-on got complex with the identity pools and the user pools of Cognito. So there are definitely trade-offs, and with the solution, the point of running a serverless system is to save costs. So anyway, with this solution sorted out, we could consume the AppSync endpoint just like we would any other. We just created a new link in our Apollo config, and this is where we kind of come back to the world of what we know. But the actual solution itself was small and straightforward, but like I said, they'd just been married. So there was little to no documentation on this. I would be joining Discord channels and Slack channels, trying to figure out which piece of my Jenga I'd place and where it worked and how it all fit. And to me, the main benefit of running serverless is the cost. And if you're running serverless, you want cheap cost and you want one endpoint. GraphQL's got your endpoint covered. And then with the cheap cost, if you're spending 6 months of developer resources to build a serverless API, you're really not saving any money. So taking it all into account, serverless is good, but I would recommend against it if you're using GraphQL. So that said, forget what I just said. Because a friend of mine, John Wong, who works at Coursera, he runs one of the most bona fide genius setups I've ever heard of in my life. And he makes use of a package called Up by a company called Apex. So I couldn't show you code for the past two solutions, obviously, but in this case I can. So in this following solution, I run a service Apollo server, which like I would for an EC2 hosted solution, and this all looks the same as you'd expect. So in this case, I utilize a package called Nexus, which is a code-based schema instead of our .graphql files I've been using up to this point. But you also see I just run a regular Apollo server. So this looks as though it was deployed on an EC2 somewhere and was serving data as we'd expect. However, in order to make a transition, we can use the up CLI and the up.json configurations. So with up, we can either run up, and that will build and deploy our entire server off as you'd expect, or we can run up start, which is a custom hook in this case, which will run it locally. And you can see that I'm calling the command node app.js. That's the same way you'd start your Express server or any other server. So as usual, this is hitting localhost. When you deploy it, you'll get a real serverless URL, or you'd deploy it locally, and you could run it internally depending on how you needed to do it, such as a CI/CD system. So running it locally, you get something like this, where it basically powers the same logs as you'd expect from a Apollo Server Express system. And there is a little configuration required behind it, so do be aware if you do approach this. They're a little bit sneaky about the way that they handle authentication and environment variables, but that all goes away when you pay the premium subscription. If you're running this in production, $10 a month isn't a huge cost. So I'd highly recommend that you do check out Up if you want to run your GraphQL setup on serverless. I think it's one of the best ways that you can do it. So one thing to be wary of when you do run a GraphQL ecosystem, is you're not bringing a lot of cons, but there are definitely some. Most notably of which is going to be your schema management. So if more than likely you're rolling a REST ecosystem now, you'll have over 100 routes. And irrespective of your puzzle, the pieces of this schema management are going to be scattered and verbose, to say the least. So when you come to the GraphQL ecosystem, you're going to be able to condense and remove, I'd easily say about 50%, if not more, and the other 50 you're going to convert into resolvers. However, the problem with this approach is that these resolvers will be heavily structured. So you'll now be able to get a variety of different data with different variations of your query strings. However, the fundamental bone structure to that get and that server will be baked into your app. So for the world of websites, this, as far as I've experienced, doesn't actually matter too much. There are variations depending on how big your team is, and Coursera runs this, Facebook runs this. These are problems they have and they solve. However, if you're running a mobile application, this can and it will ruin your life. And what I mean by that is if your client is programmed to send the user's ID of 123 to the server to then retrieve relevant data, what are you going to do if, in order to handle table limits, you change your ID to be a UUID? So in the world of web, everyone's using the same website, so it doesn't matter. But if you've ever worked in mobile development, for whatever reason, you have the users which run version 0.01 on their brand new iPhone 11. They just refuse to upgrade. So their schema is going to be super out of date with what you want. So there are certainly workarounds for this, all the way from different typing. You can just run blanket deprecation statements. You can look at the work that GraphQL and Facebook are doing to solve this. Facebook has an entire team dedicated around this. But I really think it's important to highlight that changing your schema can, and it certainly will, cripple certain functions of your app. An example of when this backfired for us at Tanda was when we launched a shift creation feature. So this feature was designed around creating shifts, and we had it programmed to send an integer. And then before we launched it live for internal testing, we changed it to be a float. And unbeknownst to us, this ended up breaking the app for quite a few people for about 2 days. And thankfully, it was internal testing, so we can message them, tell them to upgrade. But if this was a production system, there's a high chance that it just wouldn't get upgraded. And even though it does break, doesn't mean you want to just say, update your app, it's our fault, not yours. So fortunately, this was internal testing, it didn't really matter. So to summarize briefly, I just want to leave you with a quote. Great minds discuss ideas, average minds discuss events, and small minds discuss people. Supporting a GraphQL API may start off as a great idea, but it's no small task. So don't be afraid to reevaluate and walk away. If you want it because it's cool for the hip new thing, then you're looking at it for the wrong reasons. In my personal opinion, the #1 goal of any API is to reliably serve data. However, that doesn't just mean to your app. Our entire web ecosystem is powered by integrations, anywhere from a simple sign-in with Facebook all the way to a complicated payroll integration like what we run at Tanda. It's important to keep in mind that not everyone can or wants to consume your API, and a poorly designed API can limit the usability of certain clients. Secondly, be aware of schema changes. As I said, if everyone's running the same version of your app, you'll theoretically never encounter this, but your schema doesn't always stay in the same place. It's a must for you to check out Gago's talk tomorrow, about segmenting a schema and managing the problems around that.
As your team grows bigger, ownership of different aspects of the schema will eventually end up fragmenting, and this can cause you real problems if you don't manage it and use it properly. So lastly, it feels a bit moronic to be talking about SOAP at a GraphQL conference of all things, but there are serious pros and cons to both approaches. GraphQL has some stark similarities to all the pros of SOAP without all the drawbacks, in my opinion. If you're a tech lead who worked with SOAP and are wary of this GraphQL thing that your juniors keep telling you about, take some comfort in what I've said today. If I've successfully sold you on or scared you off GraphQL for your company or your products, I'd love to send you to Ankit's talk REST to GraphQL later today at 4:30. Thank you so much for having me, GraphQL Asia. Please do come chat to me after if you'd like to chat. I'm a pretty open book. Appreciate you taking the time. I think now we're going to go grab some lunch outside for half an hour and then come back to hear about how PayPal improve their checkout conversions with GraphQL. So thanks a lot, guys. Appreciate it.